Today we are doing the electromagnetic induction lab. I'm going to drop a magnet through this coil of wire. As the magnet falls through the wire, the changing magnetic flux is going to induce an EMF. We will measure that. We'll measure that as voltage across the terminals. The 850 is going to record the voltage levels. We will record this changing voltage as a function of time. You will take that data, do some integration with it to see what is the total flux from this magnet falling through the coil of wire. Now, when I was originally setting this up, I had problems getting a good consistent set of data. I learned that part of the problem was I needed to get a nice tight tube to drop the magnet through. If we don't do that, the magnet might tumble, the pole might go in a random orientation. So I'll have a question for you. Think about what would happen if that were the case. How would that alter your data? So let's go with some good data here. I'm going to take this magnet, have north pole facing down. I have this tube set so it's about 5 centimeters above the top of the coil. We'll get a good consistent set of data. You will see 3 data runs here. I'm going to click on record. I'm going to drop the magnet through, and we've got a beautiful set of data. So we have a nice positive peak and negative peak as the north pole goes through, and then as it passes through, the south pole goes through. Remember from Lenz's law, how does the EMF change as the magnet drops through the coil? You're going to integrate both of these and see, do they come out exactly equal? Are there other things going on? A lot of interesting data for you. Now I'll have a second set of data where I drop this south pole down. You will take that data, analyze it as well. I want to show you just a few more things. Just a couple things for some other pieces of data. You'll see this one, we call it the north pole down from the high drop. Here we're doing the same, north pole down. I'm dropping from a much higher position, starting from way above here. I'm going to hit record, drop it. As we go, you will observe it as it goes through. There's a much higher peak voltage, much higher peak, a higher valley. Why is that the case? What's different when the magnet falls from a higher position? We have one last piece of data that I'm going to record. This one can be a little problematic. I'm going to take 2 magnets. The 2 magnets together, how is that going to change the total flux? You need to think about that. I'm going to put these magnets together very gently. If we were doing this in class, I would beseech you to be very, very careful. These can take your skin off if you let a little flap of skin come between them. I'm going to set this time I'm going to set the magnet inside the coil. I'm going to get it started there. So there's something different going on. We're actually beginning with the magnet partly in the coil. That's going to change the total flux. So I'm going to start, let it drop, and we're going to observe something. You'll see some results. I've collected some data for you. You'll see what's happened there. All right, and that is the electromagnetic induction lab.